Topic 4-8, Factoring Completely Again. This is the last topic in this Unit 4, and this can be referenced with our whole textbook, Chapter 8, Section 6, on page 566. So we're going to do more of trying to first find the greatest common factor. So in each one of these, we'll look for first a greatest common factor. So again, I start with the variable. If there is a variable in every term, then we go ahead and put it in our, like a division bar underneath. Then you look at what's common between your whole numbers, and that would actually be a 3. 3 can be divided by each of those numbers. So our greatest common factor is a 3x. That is placed on the outside of the parentheses, and then you're just performing division. This is going to leave you with just an x squared, a negative 5x, and a positive 9. Now you can draw your box over here, but for terms of some of these, you need to realize that some of these will not factor. There's nothing that's a product of 9 other than 9 and 1 and 3 and 3, and there's no way I could get an add-in of a negative 5x. So this is actually one that won't factor anymore. So if it won't factor, you would leave your completely flat factored answer as this: 3x parentheses x squared minus 5x plus 9. And leave it in terms like that. We've gone completely factored. Okay, so this one is actually there's not a variable common with both terms, but there is a way we can divide out of 5. So 5 is your greatest common factor. So looking at what this would be divided, that's 4x squared minus 9. So I gave you a hint. This is actually a difference of squares. If you think about being able to factor a difference of squares, think of square rooting. You can take the square root of the front and the square root of the back, so that in its factored form, I'll go ahead and put it up here, this is going to be a 2x, because the square root of 4x squared is 2x. The perfect square of 9 is 3. If you lose the middle term by one being positive, one being negative. If you need to review that, just think if you multiplied this outside two factors, you're going to get 6x. Then you multiply the two inside factors, you're going to get a negative 6x. Notice 6x and negative 6x give you 0, so they factor out. That's why there is no middle term in this binomial. Okay, what can be factored out here? Not an a, because there's not an a here, but you can factor out a 4. So your greatest common factor is 4. I'll put the box here, so let's use this one. If you're factoring out a 4, let's get the new trinomial. Divide and you'll have 3a squared minus a minus 2. So 3a squared here, negative 2 here. So what is it we're looking for on this one? Is products to get to negative 6a would go also this way. Remember, you're getting your product of a negative 6a squared that way, a product of negative 6a squared that way. That gives you, in these two open blocks, what's going to give you a negative 1a. So products of 6 that would give you that is a 2a and a negative 3a. Again, when I break the 3 to the outside, I'm not going to put it here because there's nothing I can multiply by 3 to get 2. So put your 3a here with your a there. This would be 2, and this is negative 1. So in its complete factored form, you've got 4 times a minus 1 times 3a plus 2. So this box trick is quite handy in figuring out its factored form. Okay, looking at number 4. The greatest common factor on this one, look closely. Is there anything I can multiply? No. So there actually does not have a common factor. But again, we're going to notice it has a minus sign, and it also could possibly be a difference of squares, which it is. Taking the square root of 81 and the square root of 49 would allow you to have two binomials being exactly the same except for the sign between them, being a minus 7 and a plus 7. So take a look at that again. That's a difference of squares. For number 5, the greatest common factor we can find, 14 won't go into 21, and make sure you take the negative with it. A negative 7 would, and also an x, because there's a common x in both terms. So this becomes negative 7x, and when you do the division, you get 2x squared. Actually, two negatives make a positive, so that's going to be plus 3. That's not a difference of squares, so this actually is completely factored. Okay, last one. Because this is an 11, that's a prime number, there's none on this one either. There's no greatest common factor on that one. But let's do our box technique for this. Go ahead and put your 12a squared here and your 2 here. Multiplying those two together is going to give you the 24a squared. So what I multiply in this direction is also going to give me a 24a squared, but an add-in of 11. So think about what would give you that. The factors of 24. That'll give you 11. I know I'm getting a little fast at this, but you're going to get fast at this too. Alright, so again, you're looking at where our numbers are going to come from. This one's a little bit trickier, but do think if I'm breaking 12 into its factors, I've got to think of something that's going to go into 12 and into 8 that's a factor of 12. And the only thing that could be is the 4. So your 4a is going to go here. Your 3a can be multiplied here with just a 1, positive 1. And here, this can, 4a and a 2 could get you to 8a, and there's your multiple of your last digit. So this binomial is 4a plus 1, 3a plus 2. And that concludes the final topic in Unit 4, 4-8.